reaction rate. Chemical reactions can occur at different speeds. Reaction rate is a measure of how fast a reaction occurs. It can be measured by how quickly a reactant disappears or how quickly a product appears. Reaction rate can be altered by temperature. So if we increase the temperature, we increase the reaction rate because at higher temperatures, the reaction rate is faster. For example, food placed in an oven that's warmer cooks faster. Fresh fruit and vegetables placed in the fridge slow down their chemical reactions or their ripening, which is a chemical reaction. We can also alter reaction rate by stirring. Stirring a chemical reaction will increase the rate of reaction. Surface area. The more surface area that is in contact between our reactant molecules, the faster the reaction rate. So, like a sheet of metal versus a metal filings, the metal filings have a much larger surface area because whatever's reacting with it can touch the metal on all different sides versus just one side, the top of the sheet of metal. Concentration. The higher the concentration, or the more molecules of reactant per unit of volume, the faster the reaction rate. Reaction rates can also be influenced by catalysts. A catalyst is a substance that speeds up the rate of reaction without being changed itself. So when we have our reactants turning into products, rather than adding the catalyst as a reactant, it doesn't get used up. So it can't actually be listed as a reactant itself. A catalyst, if used, is placed over the reaction arrow to say that we added something to speed up our reaction, but it was never consumed or used in our reaction. So it doesn't affect the amount of products produced, it only affects the speed of our reaction. So if a reaction is really slow, maybe it takes 10 minutes. My reactants will turn into our products in 10 minutes. Okay, and I'll get a specific amount of product from that. If I use a catalyst, maybe it takes my reaction 1 minute. However, I still get the same amount of products at the end of my reaction with a catalyst after 1 minute as I would have without a catalyst after 10 minutes. The production of vegetable shortening, synthetic rubber, octane gas, they're all chemical reactions that occur with the help of catalysts just to speed them up. An enzyme is just a natural catalyst. So it is an example of a catalyst that happens naturally. It's made by living things and it helps reactions specifically in the body or in plants break down food because we want that process to be moderately fast. We don't want to be waiting. So enzymes help us to speed up that process. The enzyme specifically in saliva acts as a catalyst to start breaking down starch molecules in our mouth rather than waiting for digestion in our stomach or in the rest of our digestive tract. So often in manufacturing, we want to speed up reaction rates. So we use a lot of those processes we just discussed. However, there are times that we want to slow down reaction rates. So we use what's called an inhibitor. It's a substance that slows down the rate of a chemical reaction. So plants contain inhibitors in their seeds to prevent the germination until the conditions are right. So a seed will not grow until it has light and warmth and water. Because if a seed starts to sprout without one of those, the seed will die and the plant will never reproduce. Inhibitors are also added to food and medicines to slow down decomposition. So for instance, hydrogen peroxide, what you could use in a first aid kit, breaks down into water very quickly, water and hydrogen gas. So because we want to slow that down, we want the hydrogen peroxide in our bottle to stay there so that when we need it for a first aid emergency, it's not just water we're adding. We add an inhibitor to the bottle to slow down that reaction, so extending the shelf life of our hydrogen peroxide. Corrosion is a slow chemical change that occurs when metal or rocks are in the presence of air and moisture. So they need oxygen and water to rust. This is slow. However, we probably don't want this reaction to happen, so we're probably going to slow it down as much as possible. So one type of corrosion is rust. Rust is when we have iron and oxygen in the presence of water, which isn't in our chemical reaction. So what must water be acting as? Water makes iron 3 oxide. I should say iron 3, not iron 2. So iron 3 oxide is rust. Again, we don't want corrosion to happen. It deteriorates our metals, and it's probably something we've bought and are using for some purpose that we don't want to replace or have rust. So ways that we can prevent this is applying a thin coating of paint. If oxygen and water cannot make contact with the metal because it has been painted on all sides, then this piece of metal cannot rust. However, if our paint chips away at one spot and our metal is now exposed here, now oxygen and water can start to rust it, and it will continue along this piece of metal, lifting the paint. We can also galvanize. Galvanization is a coating when we coat a corrosive metal with zinc. So if we have our iron metal, we can coat it with a layer of zinc instead. Zinc does not rust. So because it is completely enclosed again, oxygen cannot make contact with our metal, our iron, and it cannot start to rust. Another thing we can do is electroplate. Electroplating is the process of coating a corrosive metal, like iron, with another metal through electrolysis. This just gives a much thinner coating. And the reason we want a thinner coating is we are using more expensive metals to coat a less expensive metal. So for instance, jewelry is often coated. So we'll have a cheaper metal on the inside maybe of a ring, and we will electroplate it with a more expensive metal on the outsides of the ring, so that we're not paying for the entire mass of this ring with an expensive metal, but also sometimes we get different properties. So for instance, gold is very malleable, meaning that it can be crushed really easily. So oftentimes, some jewelry can be made out of a stronger metal underneath and then simply electroplated with gold to give it that color, yet we still have the strength of the metal underneath. Combustion is a highly exothermic reaction with a substance and oxygen. It requires heat, oxygen, and a fuel. Okay, the heat is to get it started. So burning gasoline in a car, natural gas in a furnace, food in our body, propane in a barbecue. So some fuel plus oxygen makes carbon dioxide, water vapor, and energy or heat. So rather than maybe saying heat, maybe it requires a spark. And that is just to ignite and start the reaction. It doesn't need a spark to continue the reaction. The products of combustion are not always beneficial. So we typically see that we are producing CO2 and water vapor. So water vapor is fine usually. Carbon dioxide, however, is starting to contribute to greenhouse gas emissions. Additionally, if we have large fires burning, smoke, soot, and ash begin to cloud up our atmosphere. It also produces heat, which can ignite new reactions. Carbon monoxide can be produced in place of carbon dioxide. Carbon monoxide is poisonous. So, when a fire is burning in a confined space with limited oxygen, we start to get carbon monoxide instead of carbon dioxide. This is very dangerous. Other things that we can get as a product of reaction are sulfur and nitrogen. This is a problem because these are much more toxic than carbon dioxide. This happens if our fuel contains sulfur or nitrogen molecules, or atoms, So, based on the law of conservation of mass, if our fuel has C's, H's, maybe an N, I can't just make, and remember it would have to react with oxygen, I can't just make CO2 and water vapor, because that takes care of these atoms, but I haven't balanced for nitrogen. So we make some sort of nitrogen oxide, and these are much more toxic. Same thing would happen if this was an S instead. We would have to make some sort of sulfur oxide, which are much more toxic than CO2. For practice, complete the learning guide for topic 8, the rate of reaction, and there's always extra practice at the end of each topic in your textbook if you're looking for more.